Hi everyone, so we're going to start going over again today, just talking about more of this homeostasis of our bone tissue. So the first part, reabsorption, when we need to either reabsorb different calcium or we need to repair bones, we're going to use a process where something called, remember, osteoclasts reabsorb that bone tissue. And I want to make sure that we make a note that osteoclasts are going to be the cells that chew bone. So this is breaking down the bone, taking it away, where the opposite, deposition, is a process where osteoblasts replace bone. Remember, another note here, osteoblasts are going to build bone. So this is really important that we understand the difference between these two words. Osteoclasts are going to chew bone, we're breaking it down, where osteoblasts build bone. And these two are going to be really important in the homeostasis, our calcium feedback loops that we did in class. This is where you're going to see the importance of that here. So next we're going to talk about different factors that are involved with bone development, growth, and repair. So the first one is nutrition. So our bones are going to require vitamins A, C, and D to be super strong and healthy here. Another is exposure of sunlight. So remember, vitamin D is actually that vitamin that we can produce. So getting exposure to sunlight is going to help with that production of that vitamin D, because those UV rays in our skin is going to produce vitamin D. The next one is hormonal secretions. So different secretions like human growth hormone, HGH, is going to help with our growth as well. So this is very active when we are children because we have those rapid growth. So an example, we see pituitary dwarfism, where there's too little HGH being secreted during childhood. So we see a smaller person, very short, but they have normal body proportions just because they didn't receive this type of hormone. They're also going to see achondroplasia, which is a dominant inherited disorder, and this creates abnormal body proportions. So we could see really short arms because our epiphyseal discs are going to close too early, so we'll have shorter limbs here. Another is pituitary gigantism. So this one is the opposite. We'll see too much HGH secreted during childhood, and this person is actually going to end up being about 8 feet tall, which is way above the human average. And then our last one is acromegaly, where too much HGH is secreted during adulthood here. So we see our hands, feet, and our jaw are going to enlarge here, because we know as soon as our growth plates are closed in our limbs, they can no longer grow. So these are the places where we're going to see growth. Another hormone we're going to see is thyroid hormone. And we talked a little bit about this with our calcium replacement, but it also stimulates the replacement of cartilage in our epiphyseal discs of our long bones for bone tissue. So as we grow, our thyroid hormone is going to replace that cartilage so we can continue to grow taller. Another hormone that affects bone growth is actually going to be our sex hormones. So in male, they're called androgens. Females, they're called estrogens. And these are going to stimulate the ossification. So remember, ossification means turning to bone. The ossification of those growing discs. So the effect of estrogens on discs is somewhat stronger, which is why females grow quicker and then stop growing faster than males. So remember, we talked about females usually hit full growth around the age of 18, where males can grow up to the age of 25. So again, females typically reach our maximum heights earlier than males. Another one that's going to affect bone growth is physical exercise. So this stimulates bone growth with that weight-bearing exercise. It helps strengthen our bones. So when skeletal muscles contract, they're going to pull on their attachments on the bones. So when they pull on these attachments, it results in some stress and stimulates our bone tissue to thicken and strengthen. And this is going to be called hypertrophy. So this is good when we have that weight-bearing exercise. Our bones are going to thicken and strengthen. But with a lack of cells, our bones are going to be thin, and this is called atrophy. So there are a couple different divisions of the skeleton that we're also going to talk about here. So there's two divisions that we mainly see, and it's called the axial skeleton. So the axial skeleton is going to include the skull, the hyoid bone, our vertebral column, our thorax, and our thorax. So all of this we're going to see in a second is included with this axial skeleton. So if we take a look at our skull, we can see we have a lot of different bones on our skull, but we also see that there's a lot of different characteristics that go with these bones. So some ones I want to point out: our parietal bone is on the side of our head, our frontal bone is in the front. We can see our lacrimal bone, our ethmoid bone. These are found inside of our eye socket. They look a little bit different too when we see them from a different perspective. We can also see our xiphoid bone, which is inside of our nose, our temporal bone, which is the side of our head, our zomer, which is another bone that's inside our nose. Our nasal bone makes up our nose bridge. We can also see our sphenoid bone back here on the inside of that eye socket. Zygomatic bone makes up the arch of our cheek right here. Our maxilla is the top of our jaw, and the bottom is called our mandible. So we can see these a little bit differently. I'm going to point them out again. Parietal is on our side. Adding a few more, we can see our occipital bone is the back of our head. Our temporal makes up where our ear is underneath the parietal. We can see our frontal, our sigmoid right on the side, right behind our eye. And we can see all these different bones of our skull over here. We also have something called sutures, and those are going to be these lines that connect our bones. So as we grow, we know our skull had fontanelles before, had those soft spots. As we grow, those bones are going to grow together and create suture lines. Our hyoid bone is this little bone that sits just right above our larynx, so where our throat is. So underneath our mandible, we're going to see that hyoid bone. Also, the second division of our skeleton is going to be called the appendicular skeleton. So this is going to include our pectoral girdle, which is our scapula and our clavicle. It also includes our upper limbs, our humerus, radius, and ulna, carpals, metacarpals, and phalanges, which is our fingers. And it also includes our pelvic girdle, which is our two coxal bones, which makes up our pelvis. So all of this, our coxal bones, our sacrum, and coccyx makes up our pelvis here. And then we also have our lower limbs, so that's going to include our femur, patella, tibia, and fibula, our tarsals, metatarsals, and phalanges. So this is where we're going to stop here. Just remember these divisions of our skeleton. We're going to highlight these a lot more in class. Remember to let me know if you have any questions.